Imagine this. An object from another star system, something not born anywhere near our sun, comes racing past our solar neighborhood, and then suddenly it splits apart. Now, instead of one mysterious visitor, we may be staring at two. NASA and Hubble have picked up something near Mars that no one expected. Stick with me, because what they just saw could be the strangest cosmic puzzle of the year. And hey, while you're here, tap that subscribe button so you don't miss any of these stories that keep our universe so endlessly fascinating. So what are we actually looking at? The object is called 3I ATLAS. That name might sound unusual, but it simply means this. It's the third interstellar object ever discovered. The 3I stands for Third Interstellar, and ATLAS is the name of the telescope survey that found it. Only 3 times in human history have we spotted something drifting into our solar system from far, far beyond. The first was Oumuamua back in 2017, the cigar-shaped enigma that left astronomers arguing for years. The second was Comet Borisov in 2019, a much more ordinary-looking comet, but still important because it wasn't from here. And now our third guest, 3I ATLAS. But unlike the others, 3I ATLAS seems fragile, unstable. And that instability might be exactly why astronomers now think it could have split apart. Before we dig into the details of the split, let's slow things down and set the scene. Why does spotting an interstellar object matter so much? Well, almost everything we see in the sky, the comets, the asteroids, even the dust, all of it was born here. It's part of our solar system's family, leftovers from when the planets were made. But an interstellar object? That's a stranger. It's drifted for who knows how many millions of years, carrying the fingerprints of another star system entirely. Think of it like this. Imagine you've lived your whole life in one small village. You know the soil, the plants, the houses. Then one day, you find a bottle washed up on the riverbank, and inside is a note written by someone from another world. That's what 3I ATLAS represents, a cosmic message in a bottle. Except, instead of paper, its story is written in ice, rock, and dust. Now, here's where things turn strange. As it moved deeper into our solar system, astronomers began noticing something unusual. A faint second signal appeared near its projected path. Some data suggested that what we thought was a single object might actually be two. One, the main body of 3I ATLAS, and another, a smaller companion, possibly a fragment that broke away. If this is true, then this would mark the first time an interstellar object has split apart while we've been watching it. That's historic, that's groundbreaking, but what does splitting really mean? Why does it matter? Let's take a moment to rewind to one of the most famous cometary breakups in history, Shoemaker-Levy 9. Back in 1992, this comet passed too close to Jupiter. Jupiter's immense gravity tore it into a long chain of fragments, like pearls on a string. And then, 2 years later, in 1994, those fragments slammed into Jupiter's atmosphere, one after the other. The explosions left dark scars on the giant planet's clouds, scars big enough to swallow Earth whole. That event showed us something important. Comets can and do break apart, sometimes gently, sometimes violently, and when they do, they reveal secrets about their insides, about what they're made of, about how fragile or sturdy they are. Now, picture that same process, but with a visitor from another star system. That's the mystery we face with 3I Atlas. Did the heat of the sun cause its icy heart to crack? Did the tug of Mars's gravity pull it apart? Or was it so weak to begin with that this was inevitable? Right now, telescopes like Hubble and ESA's deep space instruments are still checking the data. The signal was faint. It could be noise. But if it's real, if 3I Atlas really has split into two, then we're watching history unfold in real time. And that's just the beginning. Because once we start asking why it's split, we run into bigger, stranger questions. Questions about its origin, its structure, and what it could mean for the future of interstellar exploration. So, let's step back for a moment. What exactly is an interstellar object? And why do astronomers lose sleep over them? Think of our solar system as a bubble. For billions of years, that bubble has held on to its rocks, its ice, its planets, and all the leftovers from creation. Most of what we see, we've seen before: comets circling back like clockwork, asteroids quietly drifting in belts, planets doing their eternal dance. But every so often, something drifts in from outside, something that doesn't belong here. An interstellar object is like a hitchhiker on the cosmic highway. It could have been thrown out of its home star system millions or even billions of years ago. Maybe a planet's gravity gave it a sharp kick. Maybe it collided with something else and got flung into the dark. Whatever happened, it ended up wandering the empty spaces between stars until one day, by pure chance, it crossed paths with us. The first time we ever noticed this happening was in 2017 with that strange visitor called Oumuamua. You probably remember the headlines. A cigar-shaped rock flying at a speed so fast it couldn't have come from anywhere nearby. It didn't have a glowing tail like a comet. It didn't behave like an asteroid. And to this day, scientists still argue about what it actually was. A piece of a planet? A shard of a comet? Or something we've never even imagined? Then, just 2 years later, another arrived, Comet Borisov. This one looked much more familiar. A bright tail of gas and dust, the classic signature of a comet. Except its orbit proved it was not from here. It was born under a different star, carrying frozen materials older than our own Sunday. For astronomers, Borisov was a gift. It showed us that other solar systems build comets too, and they're not so different from our own. And then came the third, 3I Atlas. Discovered by the Atlas Survey telescope, it looked fragile right from the start. Even when it was far from the sun, it was already shedding gas and dust in unusual pattern. Some astronomers whispered that it seemed unstable, as if it couldn't handle the heat and pull of our solar system. And now, with the possible detection of a second object near Mars, that suspicion feels more real than ever. But what does it mean for something like 3I Atlas to split apart? To understand, let's imagine a comet up close. Comets aren't solid rocks like asteroids. They're more like dirty snowballs. Frozen water, frozen gases, dust, and tiny grains of rock all pressed together over eons. They're fragile, like cosmic slushies held together by ice. When a comet nears a star, the ice starts to vaporize. Jets of gas shoot out, sometimes violently enough to crack the surface. And if the comet is weak enough, those cracks can tear it in two. Now picture that, but with an object that's been drifting in interstellar space for millions of years. We don't know what kind of stresses it's endured. Radiation, impacts, temperature swings from one extreme to another. By the time it reaches us, it could already be hanging by a thread. And here's the twist. If 3I Atlas has split, that might be the best scientific gift we could ask for. Because fragments reveal the inside. They show us what the object is truly made of. Astronomers dream of this kind of opportunity, a natural dissection of an alien traveler. But it also opens up big, unsettling questions. If it did split, where are the fragments going? Could one change course slightly, drifting onto a new trajectory near Mars, or even toward Earth? The chances are low, of course, but that's exactly why NASA, Hubble, and ESA are keeping such a close eye on the data. One small object can become two, and two can sometimes become many more. And that brings us back to history, because we've seen this before. Comets have a habit of splitting. Some fall apart so thoroughly they vanish entirely, leaving only a ghostly dust trail behind. Others break into pieces that live on, orbiting the sun as a family of fragments. Shoemaker-Levy 9, as we mentioned earlier, slammed into Jupiter in a spectacular chain reaction. And there are dozens of lesser-known examples, where a comet simply crumbles and fades. The difference this time? 3I Atlas isn't one of ours. It doesn't carry the familiar fingerprints of our solar system. Every crack, every grain of dust, every molecule of gas it sheds tells us about a place far away, about the chemistry and physics of another star's backyard. So, what's next? The challenge now is patience. Telescopes are scanning, computers are crunching numbers, and scientists are carefully checking. Did they really see a second object, or was it just noise in the data? If it's real, can we track both pieces separately? And if we can, what story will those two fragments tell us about their long journey through the dark? For now, all we can do is watch and wonder. When a comet splits, the drama is rarely visible to the naked eye. To us, standing under the night sky, it might look the same, just a faint dot drifting among the stars. But deep in the data, telescopes see the truth. Brightness changes, patterns shift, the orbit grows more complicated, and then, one night, there it is. A second speck of light, trailing behind the first. If the reports are correct, that's exactly what may have happened with 3I Atlas. Somewhere along its path toward Mars, it might have cracked, releasing a companion, a fragment, a twin born of pressure and time. To understand why that matters, we need to think about comet behavior more carefully. Comets are fragile, but they're also unpredictable. Some last thousands of years, circling the sun again and again, like Halley's Comet. Others fall apart in one dramatic swoop. And sometimes, the split changes everything about their journey. Take Comet Shoemaker Levy 9. In 1992, it was captured by Jupiter's immense gravity and torn into more than 20 pieces. For 2 years, those pieces stretched out into a long train, like pearls on a string. Then, in 1994, one by one, they plunged into Jupiter's atmosphere. The explosions were so powerful that Earth-based telescopes could see them. It was the first time humanity had ever witnessed a collision between two bodies in the solar system in real time. And it reminded us just how fragile and violent the universe can be. Now, compare that to something like Comet 73P divided by Schwarzmann-Bachmann, a mouthful of a name, but a story worth remembering. In 1995, it began to fall apart. Over the years, it fragmented into dozens, maybe hundreds, of smaller pieces, each glowing faintly as they drifted along the same orbit. To this day, astronomers keep track of its family of fragments, each one a clue to the comet's original makeup. So here's the question. If 3I Atlas is truly splitting, which path will it take? Will it be like Shoemaker Levy 9, breaking into a few dramatic chunks that cause a brief but spectacular event? Or will it be more like Schwarzmann-Bachmann, scattering a trail of fragments that linger for decades, even centuries, as cosmic breadcrumbs of an alien traveler? The answer depends on what it's made of, and that's the problem. We don't know. For comets from our own solar system, we've built models. We know the typical ratios of water, ice to carbon dioxide, of dust to frozen gases. We can even guess how strong or weak a comet's core might be. But 3I Atlas is different. Its chemical fingerprint doesn't match what we've seen before. When scientists first analyzed its emissions, they found ratios that looked strange, unfamiliar, almost out of place. This is where things get interesting. If its chemistry is unique, then its structure might be unique too. Maybe it's more brittle than we expect. Maybe it's tougher. Maybe the heat of the sun is making it fracture in ways we've never witnessed. That's why this second object, if confirmed, is so important. It's like peeling open a cosmic mystery box. But the mystery also brings a quiet unease, because when objects split, their paths can shift. Even a tiny nudge, a puff of gas, a crack in the surface can send a fragment drifting onto a slightly different orbit. 99 times out of 100, it doesn't matter. The fragment stays in deep space, far from us. But once in a while, it matters a lot. That's why the detection near Mars raised eyebrows. Mars is safe, of course, but the fact that the fragment could be drifting in that region means it's not just trailing obediently behind its parent. It might be carving its own path now. That's a big deal. Because once a fragment has its own orbit, it becomes its own traveler, unpredictable and worth watching closely. NASA's telescopes are scanning. Hubble has already been pointed at the object more than once. ESA's network of instruments is feeding back new data. And in quiet offices around the world, scientists are doing what they always do: checking, rechecking, running simulations, and asking, what if? What if the split is real? What if the fragment drifts away completely? What if it doesn't? For now, there are no clear answers. But every hour, every new stream of data brings us closer to understanding. And yet, here's the thing. Even with all this careful science, there's still a deeper layer of wonder. Because when you look at 3i Atlas, not just as a puzzle, not just as a risk, but as a traveler, it becomes something more. It's not just an object, it's a messenger, a piece of another world, carrying secrets across millions of years, now breaking open right in front of us. And we have to ask, what story is it trying to tell? The possibility of a fragment drifting near Mars opens a door to new questions, not just for astronomers, but for anyone who wonders how fragile the dance of the planets really island. Because in space, small changes can mean big consequences. Think about orbits like invisible highways. Every planet, every comet, every tiny speck of dust has its lane. They loop around the sun, pulled by gravity, guided by momentum. Normally, it's all predictable. But when something breaks, when a comet splits, it's like tossing debris onto a busy road. The lanes get messy, paths cross, and suddenly, you don't know who's going to bump into who. Mars is not in immediate danger, of course. Its atmosphere is thin, but it still shields the surface from smaller debris. And most comet fragments, even large ones, are icy and fragile. If they approach a planet, they often burn up before they ever touch the ground. Still, scientists watch closely because every fragment is a new variable in an already complex system. And here's where it gets even more fascinating. Mars isn't just another planet in this story. For us, it's a frontier, a place where we've sent rovers, orbiters, landers, a place where Elon Musk and SpaceX talk about building cities, a place that might one day hold human footprints. So, when something unusual drifts near Mars, people notice. Not just scientists in their labs, but engineers thinking about spacecraft safety and dreamers thinking about future colonists. Because if a comet fragment can wander into that neighborhood, it's a reminder that space is not empty. It's dynamic, it's alive with motion and risk. Now, history gives us some context here. Earth has been hit before, many times. Some impacts were small fireballs streaking across the night sky. Others were catastrophic. 66 million years ago, a fragment of rock or ice slammed into Earth's surface, ending the reign of the dinosaurs. That wasn't a comet split, as far as we know, but it shows the stakes. In the cosmic casino, even one unlucky roll can change everything. For Mars, the stakes are different. It's not teeming with life, at least not that we know of. But every fragment that passes by is a chance to learn. If a piece of 3i Atlas came close enough, and if we had instruments ready, we could study its composition directly. It would be like catching a shard of another world, a sample that could tell us what materials drift between stars, and maybe even hint at what kinds of chemistry are possible in distant systems. But here's the twist. Some astronomers aren't just asking about science, they're asking about patterns. Because if 3i Atlas is splitting earlier than expected, if it's shedding fragments already, it could mean its core is unstable. And if its core is unstable, then its future path might not be as predictable as we thought. That's where the problem begins. When a comet breaks apart, the smaller pieces don't always follow perfectly in line. Some lag behind, some drift ahead, some spread out into wide arcs, and in rare cases, fragments can be pushed into slightly new orbits that bring them closer to planets or closer to us. Nobody is sounding alarms. This isn't a doomsday scenario, but it is one of those moments where the scientific community leans forward, watches carefully, runs the models again and again. Because even if the risk is tiny, the knowledge is priceless. And here's something worth remembering. When we look at the sky, we often see stability. The moon rises, the sun sets, the stars wheel overhead. It feels eternal, permanent. But in truth, the universe is in motion. Comets split, planets wobble, stars explode. Stability is an illusion. And events like this, a fragment drifting near Mars, are reminders of just how delicate the balance really is. So the question becomes, what happens next? Will this fragment fade quietly into the dark, unnoticed except by telescopes? Or will it reveal something unexpected, a shift, a flare, a clue that 3I Atlas is not behaving like any comet we've seen before? The story isn't finished yet, and that's what keeps astronomers awake at night and keeps the rest of us staring at the stars with a mix of wonder and unease. To understand the true weight of 3I Atlas and its mysterious behavior, we need to step back in time, because this isn't the first comet to break apart before humanity's watchful eyes. In fact, history is marked by fragments, shattered travelers that left both wonder and warning across the skies. Take Comet Shoemaker-Levy 9, for example. In the summer of 1994, astronomers around the world watched as it split into more than 20 pieces and hurled itself toward Jupiter. For days, the fragments plunged into the planet's atmosphere one by one, creating explosions so vast they could be seen from Earth through backyard telescopes. Each impact released more energy than the strongest nuclear weapons ever built. It was a stark reminder comets are not just icy ornaments of the solar system. They are messengers of destruction. And when they split, their fragments can carry enough force to scar a planet forever. But Shoemaker-Levy wasn't the first. Centuries earlier, another comet broke apart and changed the way humans thought about the heavens. In 1846, a comet was observed dividing into two luminous bodies. For years afterward, astronomers traced both fragments as they wandered separately through the solar system. That split became one of the earliest proofs that comets were fragile, not solid, indestructible wanderers. And yet, the phenomenon goes even deeper into history. Ancient records tell of comets that appeared with twin tails or that seemed to multiply in the night sky. To people of the past, these weren't scientific puzzles. They were omens, warnings, symbols of change or catastrophe. Kings trembled, armies hesitated. Entire societies wondered if the heavens themselves were trying to speak. Today, we view them differently, but the echo remains. When a comet like 3I Atlas breaks apart, it awakens the same old fears. Because even with science, we cannot control the outcome. We can only watch, measure, prepare. Now, what makes 3I Atlas unique is not just its size, which, remember, some estimates place at several kilometers across, but its trajectory. Unlike Shoemaker Levy 9, which was bound for Jupiter, or those earlier comets that quietly faded, 3I Atlas comes from beyond. It entered our solar system not as a neighbor, but as a stranger, an interstellar visitor that may not return. That changes everything. Because when a comet from deep space breaks, it's like opening a sealed container. Inside could be ices, gases, or compounds we've never studied before. Materials untouched since the birth of other stars. And when those fragments drift, they scatter across the solar system like seeds in the wind. Some will disintegrate, some will vanish into the void, but others just maybe could wander into planetary paths, and that brings us back to Mars. That drifting shard that caught astronomers' attention could be the first of many, a sign that 3I Atlas is unraveling and that its pieces will scatter like a trail of breadcrumbs across the inner solar system. Imagine, for a moment, the sky centuries from now. Future explorers on Mars might look up and see the faint arc of a fragment burning across the horizon. Colonists on Earth might chart meteor showers born from the debris of this one comet, just as we trace the Perseids back to Comet Swift-Tuttle. In that sense, fragments are not just dangers, they are gifts. They create beauty. They leave trails that humans will follow for generations. But in the short term, they are mysteries. They force us to ask, how stable is 3I Atlas really? What if the break we've seen is only the beginning? And most importantly, is this comet following rules we know, or is it hiding something stranger? Because the truth is, interstellar comets are still new to us. We've only confirmed a handful in all of history. Some pass by quickly, unnoticed except by a few telescopes. Others flare dramatically and then fade. But every one of them feels different, alien, unpredictable. And unpredictability is what makes 3I Atlas so unsettling. If it behaves like no other comet before, then what else could it reveal? The clock is ticking, the fragments are drifting, and the universe is watching. When astronomers first whispered that 3I Atlas might be breaking apart, many minds immediately went back to one of the strangest cosmic guests of recent times. A visitor that slipped past our solar system like a shadow, leaving more questions than answers. Its name was Oumuamua. In 2017, telescopes in Hawaii spotted it gliding through the solar system. At first, it was thought to be an ordinary comet, but almost immediately, it began to defy expectations. It had no glowing tail, no predictable outgassing. It accelerated slightly as it left, almost as if it was being pushed by something unseen. For years, debates swirled. Was it just a shard of rock from another star system? An icy fragment that behaved strangely under the sun's heat? Or was it something else entirely, an artificial object, a relic of technology from a civilization we've never met? No clear answer has ever been found. Oumuamua remains a riddle written in the sky, and to this day it still lingers in scientific papers and late-night debates. Now, 3I Atlas shares something of that same alien aura. It's not bound by the gravity of our sun, like most comets. It arrived as a wanderer from beyond, a messenger from the vast dark between the stars. Its very presence is rare, and its fragmentation is even rarer. The only other interstellar comet confirmed so far is Borisov, discovered in 2019. Unlike Oumuamua, Borisov looked and behaved more like a normal comet. It had a bright tail, it shed material, and it gave scientists the first real chance to analyze an interstellar visitor up close. Even then, Borisov wasn't perfectly ordinary. Its chemistry hinted at ices formed in conditions harsher than anything in our own solar system. A world colder, more brutal, more alien. So now imagine this. If 3I Atlas is splitting apart, those fragments may be pieces of an alien world. Tiny frozen archives carrying the fingerprints of a system light years away. Dust that formed in the cradle of another star. Ices shaped under the pool of suns we will never see. That's why scientists are watching so closely. Every split, every strange flare is a clue. A chance to peek at the building blocks of worlds beyond our reach. And yet, there's another side to the story, one less romantic and more unsettling, because unpredictability means danger. Comets, especially large ones, don't need to strike a planet to leave their mark. Their fragments can create meteor showers intense enough to light the skies. Their debris can scatter across orbits for centuries. And a single impact, even a fragment only a few hundred meters across, could devastate a planet's surface. It's here that Mars enters the story again. The possible detection of a second object near its path wasn't dismissed lightly. If confirmed, it would mean 3I Atlas has begun to shed pieces that wander dangerously close to planetary lanes. Most of these fragments will likely pass harmlessly, but even the smallest chance of collision is enough to make astronomers uneasy. And here's the deeper question. What if 3I Atlas isn't done splitting? What if what we've seen so far is just the beginning of a cascade? One fracture leading to another. One fragment becoming two. Two becoming four. Until the comet unravels entirely, leaving a trail of icy shards stretching across the solar system like broken glass scattered across a cosmic floor. If that happens, the story of 3I Atlas won't end with a quiet pass by the Sunday. It will leave a legacy written in debris, in fragments that circle and fall for decades, maybe centuries to come. And so we return to the central tension. On one hand, this is a scientific gift, a once-in-a-lifetime chance to study interstellar matter breaking apart before our eyes. On the other hand, it's a ticking unknown, a reminder that the universe isn't always safe, and that sometimes the most beautiful discoveries carry shadows. Because when you stare at a comet like 3I Atlas, glowing silently in the dark, it doesn't just look like a piece of ice. It looks like a warning. When most people picture a comet, they imagine something solid, a frozen boulder sailing through space. But the truth is far stranger. Comets aren't carved from stone like asteroids. They're fragile, delicate things, often described as dirty snowballs, though even that description is a little too simple. Inside, they're a patchwork of ice, dust, and ancient material left over from the birth of stars. Imagine something like a snowbank left out in the sun, riddled with cracks and hidden pockets of air. That's a comet. And like a snowbank, it doesn't take much for it to collapse. There are three main ways a comet can split. The first is called thermal stress. As a comet swings close to the sun, its frozen ices boil, expanding and cracking its fragile crust. It's as if the comet is sweating itself apart. The second is gravitational stress. When a comet passes near a planet or even near the sun itself, the immense tug of gravity can tear it apart, pulling one piece one way and another piece the opposite. This was what destroyed the famous Shoemaker-Levy 9, breaking it into more than 20 fragments before Jupiter swallowed them in a spectacular chain of impact. And the third is more subtle but just as deadly. It's called outgassing pressure. A comet's ices don't always melt evenly. Sometimes pockets of gas build inside, trapped beneath layers of dust. Over time, the pressure grows until one day it bursts. A jet of gas erupts, splitting the comet like a balloon popping from the inside. Now imagine all three of these forces acting at once. Heat from the sun cooking its surface, gravity tugging at its orbit, internal gas boiling until it cannot be contained. A comet's life is not peaceful. It's a slow war against the forces of physics. 3I Atlas may be caught in that same war right now. Its approach has already stressed it. Its long journey from deep space, where it was frozen for millions of years, to the inner solar system, where sunlight pierces every inch, is a brutal transformation. If the reports are right, if a second object really has been spotted trailing near Mars, then the break may have already begun. What we're seeing could be the first visible sign of its unraveling. But here's what makes this case so unique. Normal comets belong to our solar system. We've seen them split, crumble, and even vanish completely. But 3I Atlas doesn't belong here. It comes from the deep dark between the stars. That means its structure might not behave the way we expect. Its eyes may be tougher or weaker. Its dust may be thicker or thinner. The rules we've learned from our local comets might not fully apply. In other words, this is not just another comet cracking apart. This is alien ice, alien rock, alien chemistry, splitting in ways we've never witnessed before. Some astronomers whisper that this might be the first time humanity gets to watch an interstellar comet die, to watch it slowly fracture, not in some distant galaxy, but right here in the theatre of our own skies. And that thought alone should make you pause, because when you think about it, these fragments are not just pieces of rock. They're the remains of a world we will never visit, of a solar system that spun its planets billions of years before ours even existed. And now, those remains are breaking open before our eyes. History has a way of preparing us for the future, and with comets, the past is filled with violent reminders. One of the most famous examples of comet fragmentation happened in 1992 when Shoemaker-Levy 9 wandered too close to Jupiter. At first, it looked like an ordinary comet, nothing out of the ordinary. But then astronomers noticed something strange. It wasn't a single bright dot moving across the sky. It was a string of pearls, dozens of glowing fragments, lined up one after another, like beads on a necklace stretched across space. This comet had been ripped apart by Jupiter's immense gravity. And in 1994, those pieces slammed into the giant planet one by one, creating explosions so large they could be seen from Earth. Each impact carved a dark scar into Jupiter's clouds' black marks that lasted for months. It was a wake-up call for humanity. For the first time, we saw what could happen if a comet were to strike a planet. But shoemaker Levy wasn't alone. In 2000, astronomers tracked Comet Linear, which suddenly broke into pieces as it approached the Sunday. No planetary tug, no violent collision, just the sheer heat of sunlight tearing it apart. Observers said it was like watching a snowflake vanish in a candle flame. Then came Comet Ison in 2013, once hailed as the comet of the century. As it raced toward the sun, excitement grew. Would it blaze across the night sky brighter than Venus? Would it be the spectacle of a lifetime? Instead, under the sun's intense glare, Ison disintegrated completely. What was supposed to be a dazzling show ended as little more than dust and silence. These stories remind us of a hard truth. Comets are fragile. Even the grandest, brightest travelers can vanish in an instant. But here's the twist. All those comets were born in our solar system. They were part of our family. Fragile though they were, 3I ATLAS is not. It comes from the far reaches beyond our sun's influence. That's why its potential split carries an extra layer of mystery. If it breaks apart, will it act like Shoemaker Levy, scattering fragments that follow one another like pearls in the night? Will it flare and vanish like Ison, swallowed by the sun's furnace? Or could it behave in a way we've never seen, guided by physics shaped in another solar system entirely? Some scientists argue that its unusual path and speed already set it apart. Unlike our comets, which loop back eventually, 3I ATLAS will likely never return. Its fragments, if real, will scatter and drift endlessly through the galaxy pieces of another star system, now forever lost to space. But there's another angle to consider. When comets break apart, the pieces don't always just drift quietly. Sometimes they create meteor showers, streams of debris that Earth may one day cross. That's the part that makes researchers watch so closely, because a second object trailing near Mars today could mean trails of dust and rock tomorrow, sweeping across the inner solar system. Could fragments of 3I ATLAS one day streak across Earth's skies, lighting up the atmosphere as meteors? Or worse, could a larger piece eventually cross our planet's orbit? These questions push us deeper into the heart of the mystery. For now, no answers are certain, but history gives us reason to stay alert. Each comet that has split before has rewritten part of what we thought we knew, and this one isn't just rewriting the book, it's adding a whole new chapter. Because never before have we seen an interstellar comet split apart within reach of our telescopes. And that makes every observation, every faint signal, every reported fragment something extraordinary. When news of a possible second object near 3I ATLAS first leaked, the astronomical world lit up like a switchboard. The whispers started in late-night observatories, quiet data rooms, and encrypted emails. And before long, the big players joined the hunt. NASA, the Hubble Space Telescope team, and the European Space Agency with their fleet of eyes in the sky. At first, it was a faint signal, not a glowing beacon or a dramatic streak across space, just a subtle dot of light moving almost in rhythm with the original comet. Too faint to call a discovery, but too consistent to ignore. The Hubble Space Telescope was tasked to check. Its ultra-sensitive optics can detect objects smaller than a city block from millions of miles away. And what it saw raised more questions than answers. Beside the shimmering glow of the main comet, there was indeed a faint companion, sometimes brighter, sometimes dimmer, but always close like a shadow in orbit. NASA scientists cautioned immediately, don't jump to conclusions. Cameras can play tricks. Light can scatter. Cosmic rays can flash across detectors and leave false impressions. But the signal didn't vanish. It persisted, frame after frame, day after day. Meanwhile, ESA's Mars-orbiting satellites were watching from another angle. Positioned closer to the path of the comet, their instruments picked up disturbances in charged particles around Mars. Nothing huge, nothing catastrophic, but subtle ripples, as if two separate objects were disturbing the solar wind instead of one. The question quickly shifted from if there was a second object to what it meant. If this is a fragment of the comet, then 3I Atlas may be unraveling under forces we barely understand. Remember, comets break apart under pressure from gravity, from heat, from stress in their frozen cores. But this object, it isn't near the sun yet. It isn't close enough for Mars to rip it apart with gravity. And yet, here we are, possibly seeing two bodies where once there was one. Astronomers compared the early images side by side. The first object, the parent, still showed the hazy halo of gas and dust that we expect from a comet shedding its icy skin. But the second? Its light signature was colder, sharper, almost metallic. That part puzzled everyone. A normal comet fragment should look nearly identical to the parent, the same mix of ice, rock, and gas. But this faint companion refused to play by the rules. Some researchers suggested it could be a chunk of the nucleus, a piece that broke off during a hidden internal fracture. Others whispered about the possibility of a binary structure where the comet had always been two bodies, locked together like dance partners for millions of years, only now drifting apart under stress. And then there's the most chilling possibility, that what we're seeing isn't a fragment at all, but something separate traveling alongside. That idea, of course, borders on speculation. Scientists won't stamp it as fact. But as the data kept rolling in, they couldn't deny the truth. Whatever this second object is, it doesn't behave like a simple snowball of ice and dust. This is where the debate sharpened. Was this an interstellar comet undergoing a natural split, the kind we've seen before with Shoemaker-Levy and Eisen? Or was this a new phenomenon entirely? Something that challenges how we classify these travelers. What makes the situation even stranger is the timing. Right as astronomers locked onto this faint second object, Mars itself was in near-perfect alignment with its path. If a fragment truly broke away, then Mars, not Earth, could be the first planet to feel its influence. The thought is sobering. Imagine a fragment even a few 100 meters wide brushing past Mars, or worse, colliding with its thin atmosphere. The shock would light up space in a way we could never ignore. For now, all we have are data points, faint signals, hints of a split. But what's certain is this: the world's telescopes are now tracking 2 eyes instead of 1, and that changes everything. The moment the second object appeared on scientific radars, the mood shifted. What began as cautious excitement over an exotic comet turned into quiet concern. Because if this wasn't just a harmless fragment drifting through space, it posed a problem much bigger than a curiosity in the sky. You see, fragments don't behave politely. Once a comet splits, each piece can follow its own path, nudged by gravity, solar winds, or even their own uneven shapes. That's why fragmentation is one of the most dangerous events in cometary science. One body is predictable. 2 bodies? That's chaos. The first big worry was Mars. The red planet has been a target of human curiosity and exploration for decades. Orbiters, rovers, and now even plans for crewed missions. If one of these fragments came too close, even without a direct collision, the dust and debris could wreak havoc on delicate spacecraft systems. Mars has no thick atmosphere like Earth to burn up incoming fragments. Out there, even a pebble moving at tens of thousands of miles per hour could be catastrophic. And then there's Earth. We're not directly in the comet's path, at least not yet. But that's the unsettling part. A split changes everything. Imagine tossing 2 stones into a river. They may start side by side, but just a little difference in angle can send them drifting apart, even miles downstream. In space, those differences get magnified over millions of miles. A fragment that seems harmless now could, years from today, intersect Earth's orbit. NASA's Jet Propulsion Laboratory ran quick simulations. Most of them showed the fragments passing safely by. But a small percentage of models showed something more worrying. Gravitational tugs from Mars could alter the path of the secondary object, giving it a new trajectory. And in some scenarios, that trajectory edged uncomfortably closer to Earth's neighborhood. Scientists don't like using the word impact risk lightly. It sparks panic. But here, the whisper of that possibility was unavoidable. Even if the probability was tiny, the fact that this was an interstellar object, something born beyond our solar system, made it different. This wasn't a body we'd tracked for centuries, mapped and catalogued. This was new, unpredictable, and possibly unstable. The challenge wasn't just physical, it was also scientific. How do you study something that breaks the rules the moment you think you understand it? The faint metallic-like glow of the second object added to the mystery. If it's not behaving like normal comet ice, then what forces caused the split? Was it internal pressure building for millions of years? Was it a violent outburst of gases trapped beneath its crust? Or something stranger? All of this has left scientists staring at screens, recalculating trajectories, and rethinking assumption. The challenge isn't just figuring out where this object is going, it's trying to understand what it really is before it moves beyond our reach. And that's the heart of the problem. Fragments don't wait for us to catch up. They move on their own time, indifferent to our questions. And unless we solve this puzzle soon, the mystery of the second object near Mars might pass us by, leaving us with more questions than answers. So what exactly could this second object be? The truth is, no one knows for sure. But there are three main schools of thought, each with their own weight of evidence and each carrying its own unsettling implications. The first explanation is the simplest: natural fragmentation. Comets are messy snowballs of rock, ice, and dust, held together by weak bonds. When they get close to a star, the heat makes their interiors boil. Gas pockets burst out like steam escaping a kettle, and the nucleus can split apart. We've seen this before, the most famous case being Comet Shoemaker-Levy 9, which broke into over 20 pieces before slamming into Jupiter in 1994. If the second object is just a fragment of Interstellar Atlas, then we might be watching a repeat of history, only this time closer to home. But there's something that doesn't add up. Normally, comet fragments fade quickly. They lose their structure, they disintegrate into smaller bits. Yet this second object seems stable, holding its form as it moves near Mars. Some scientists point out that the light signature isn't the same as the parent body either. It's dimmer, more reflective in unusual wavelengths, almost as if its surface is smoother or coated in materials we don't usually see on comets. That leads to the second idea, that this fragment might not be a fragment at all. Some propose it could be an object that was already there, perhaps a captured asteroid or a piece of debris from ancient impacts on Mars, and the timing of its detection just made it seem like it broke away from Atlas. The solar system is littered with countless small rocks, many of them undiscovered. It's possible that this second body just wandered into the spotlight at the wrong time, tricking us into connecting it with Atlas. But if that's true, then why does its trajectory align so neatly with the path of the interstellar visitor? Coincidences in orbital mechanics are rare. And then there's the third explanation, the one whispered about late at night in observatories and data labs. What if this isn't just random? What if Atlas itself isn't entirely natural? Some argue that the way it fractured doesn't match normal physics. The sharpness of the split, the odd composition, the metallic hints in the spectrum, all of it raises eyebrows. Could it be that what we're looking at isn't a comet at all, but a structure? Something artificial? If that sounds far-fetched, remember, we once thought Oumuamua, the first known interstellar object, could be a fragment of alien technology. Harvard's Avi Loeb even suggested it could have been a probe. That debate was never settled, and here we are again. Most scientists dismiss the idea of anything artificial. There's no smoking gun, no clear proof. But here's the thing, interstellar objects are rare. We've only detected a handful, and already 2 of them have shown behavior that doesn't fit the textbooks. If this second body is real, then Atlas isn't just another visitor. It's something more, something stranger. And that brings us to the deeper question. If this fragment isn't just a natural split, Then what story is it trying to tell us? Mars, the silent, rust-colored desert world we've studied for decades. Right now, it's being circled by orbiters from NASA, ESA, India, China, and even the UAE. Its surface is being explored by robotic rovers, crawling slowly across the sands, their cameras scanning the horizon. It is, without question, the most carefully watched planet in our solar system besides Earth itself. So imagine the tension when news comes in that a second object has been spotted near Mars. Astronomers on Earth are cautious, but engineers working with spacecraft immediately begin running models. Could this object pose a threat? Could it drift into an orbit that crosses the path of an orbiter? Could fragments rain down, invisible at first, only to burn into Mars's thin atmosphere or slam into the surface? NASA's Perseverance rover, for example, sits in Jezero crater, busily collecting samples. Curiosity is still alive, further away, quietly crawling across Gale crater. And China's Zhurong rover rests in Utopia Planitia. They may be safe on the ground, but if something large enters Mars's skies, it could throw off communications, disrupt signals, or worst of all, strike the surface. A direct hit, even a small one, could devastate decades of work. But it isn't just the rovers at risk. Think about the orbiters. Mars Reconnaissance Orbiter MAVE ExoMars and HOPE from the UAE. They skim above the planet, mapping, probing, sending down torrents of data every day. If the second object's trajectory bends just enough, a collision with one of these silent guardians would be catastrophic. Billions of dollars, years of science gone in an instant. Yet, here's what makes it even more curious. Preliminary tracking suggests that the second object isn't behaving like debris. Its orbit appears stable, almost too stable. It moves near Mars, but not directly into its gravity well, as if it's gliding past, unaffected by the pull. That raises red flags for scientists. A natural fragment should wobble, tumble, perhaps spiral into the Martian atmosphere. Instead, it drifts with an eerie calm, like a leaf carried by invisible currents. If this continues, space agencies may need to adjust their plans for future missions. Remember, Mars is our next big frontier. NASA aims for human missions in the 2032. SpaceX speaks boldly of building settlements. Every trajectory, every window, every orbital calculation depends on knowing what else is in Mars's neighborhood. A second body, especially one linked to an interstellar visitor, complicates all of that. For now, the world's telescopes keep their eyes fixed. The Hubble Space Telescope watches from Earth orbit. The James Webb peeks into the infrared, scanning the faint light reflected off the object. ESA's observatories gather every photon they can, and the data streams in, suggesting that whatever this is, it isn't fading. It's holding steady. Which begs the question, if this fragment is not breaking apart, not spiraling into chaos, then what is it waiting for? If this second object is real, and if its path keeps it close to Mars, the possibilities become fascinating and unsettling. Mars has always been the planet of change. Billions of years ago, rivers once cut through its valleys, Lakes filled its basins, and perhaps even an ocean sprawled across its northern hemisphere. Then, something happened. Its magnetic field weakened. Solar winds stripped away much of its atmosphere. The water either evaporated into space or froze beneath the ground. Mars became what we see today, cold, barren, and dry. But what if an interstellar fragment like the one now spotted near it could influence that fragile balance? Even a modest impact could release buried ice, creating brief floods or plumes of vapor. Imagine a chunk crashing into the polar caps, cracking the ice sheets, and sending carbon dioxide into the air. The thin Martian sky could thicken, at least temporarily. Temperatures might rise. For scientists dreaming of terraforming, that would be a natural experiment too big to ignore. There's also the other side of the coin. Mars has been a quiet world for millions of years. Its thin atmosphere means meteors usually pass through without much fanfare. But a large interstellar object, that's a wild card. A collision could not only scar the landscape, but also kick dust high into the air. The fine particles could spread across the globe, darkening the planet for months. Solar panels on rovers would weaken, communications might suffer, and any hope of a clear view from orbit would vanish in the haze. Some scientists also whisper about resonance. If the fragment doesn't strike, but instead lingers near Mars, it might nudge the planet ever so slightly. A gravitational handshake. Over decades or centuries, small tugs could add up. Nothing apocalyptic, but enough to shift orbits of its moons, Phobos and Deimos. Phobos, already doomed to crash into Mars in the far future, could meet its fate sooner. Deimos, the quieter of the two, might drift further out, destabilized. And here's a thought that lingers in the background, always speculative, always uncertain. Could the fragment carry something with it? Interstellar material, dust, or even simple organic molecules? If so, Mars might soon host the first delivery from another star. Scientists have long suspected that comets and asteroids may have brought the building blocks of life to Earth. If Mars receives such a package, it may rewrite how we think about life in the universe. But let's step back. For now, this is just possibility layered on possibility. What we know is this. Telescopes confirm a second object close to Mars, traveling with the interstellar visitor. It is not behaving like ordinary debris, and because of that, the story of Mars, a story already rich with mystery, now has a brand new chapter waiting to unfold. When we talk about fragments and impacts, it's tempting to imagine them as distant fireworks, dramatic, yes, but far removed from our reality. Yet, history has shown us again and again that even small objects from space can change a world forever. Take the Tunguska event in 1908. A space rock no larger than a house exploded high above Siberia. In a fraction of a second, the blast flattened over 2,000 square kilometers of forest trees laid down like matchsticks, animals incinerated, skies glowing strange colors for nights afterward. No crater was left behind, but the shockwave circled the Earth twice. That was just a fragment, a reminder of what even modest interlopers can do. Now, scale up to the Chicxulub impact 66 million years ago. That one needs no introduction. A rock, roughly 10 kilometers wide, crashed into the Yucatan Peninsula and unleashed devastation that wiped out the dinosaurs. It wasn't just the initial blast, though. That alone was beyond comprehension. It was the aftermath. Dust clouds choking the sky, global temperatures dropping, ecosystems collapsing. One strike and an entire age of Earth was over. And then there's Shoemaker-Levy 9. In 1994, astronomers watched in awe as a comet broke apart into more than 20 fragments and slammed into Jupiter. Each strike was bigger than Earth's largest nuclear explosions, leaving dark bruises on the planet's swirling atmosphere. Jupiter absorbed the blows, but Earth, much smaller, much more fragile, would never have survived something on that scale. So, when astronomers whisper about Atlas splitting into two, with one fragment drifting toward Mars, the echoes of these stories ring louder. Because history tells us space doesn't play favorites. Planets, moons, orbits, atmospheres, all can be reshaped in a single night. The climax here is not about fear. It's about perspective. We stand on a tiny blue world, watching the heavens with instruments so precise they can detect a fragment millions of kilometers away. We know enough to spot the danger. We know enough to study it. But we also know enough to be humbled. Because, in the end, Atlas is a reminder that the universe is still wild. It is not a quiet, orderly place where nothing ever happens. It is alive with movement, with collisions, with fragments of other stars drifting into our neighborhood, rewriting stories we thought were finished. And as Atlas's path continues to unfold, one thing is certain. We are watching history being written in real time. Mars may bear the scars. Earth may only bear the memory. But the lesson belongs to all of us, that the universe, vast and restless, is always closer than we think. So here we are. We've traced the story of Atlas, the interstellar traveler that broke apart, leaving behind fragments like clues scattered across the solar system. We've compared it to comets of the past, to planetary scars, to cataclysmic events that rewrote Earth's history. And what we're left with is not fear, but wonder, because the truth is, we live in a universe that is not still. It shifts, it collides, it fragments, and sometimes it sends pieces of itself across unimaginable distances, all the way into our backyard. The split of Atlas near Mars is just one chapter in a much larger story. A story that connects us not only to our solar system, but to the wider cosmos beyond. Each fragment is like a whisper from the stars, a reminder that our world is not separate from the universe, but a part of it. Think about it. Right now, as you listen, these fragments are out there, silent, drifting, yet powerful enough to leave a mark on planets, atmospheres, maybe even futures. And one day, another Atlas may appear, maybe bigger, maybe smaller, but always carrying with it the reminder that space is not empty, it is alive. And so the story doesn't end here. It never does, because above us, the universe keeps moving. And all we can do, all we should do, is keep watching, keep listening, and keep asking the questions that matter. Thank you for staying with me through this journey. If you want to keep exploring mysteries like this, Don't forget to subscribe and check out the next video waiting for you on screen right now. Trust me, you won't want to miss it.